Hey guys, today's lesson is on section 8.2. We'll be multiplying a polynomial by a monomial. So we're going to be multiplying a bunch of terms by one term. For this section, we are going to be using the distributive property a lot, such that we're going to distribute the monomial to each term of the binomial, trinomial, or polynomial that we're multiplying it to. For example, problem number 1, we're going to be distributing the 2 to both terms of the binomial we're multiplying. 2 times 4a will give us 8a, and 2 times 3 will give us 6. Problem number 3, we'll be distributing the x times both terms of the binomial that we're multiplying. X times 4x gives us 4x squared. Remember, when you're multiplying like variables, you're adding their exponents. And x times 3 is 3x. Lastly, in this section, we're now distributing to a trinomial. One term times 3 terms, we're going to multiply the 4p squared times all the 3 terms in the trinomial. 4p squared times 2p squared will give us 8p to the 4th. Plus 4p squared times 3p will give us 12p cubed. And lastly, 4p squared times 1 will give us 4p squared. Remember, anything times 1 is itself. In the second section, we are going to multiply a monomial times a binomial, and then we're going to add or subtract something from or to our expression. So the first thing we'll do for number 1 is distribute the x. X times 3x is 3x squared. X times 2 will give us 2x. And we're going to tack on the 5x on the end. Are there any like terms in this expression that we could combine? Yes, there are. The 2x and the 5x are like terms because they have the same variable with the same exponent. So we could combine those terms to get our answer 3x squared plus 7x. Similarly, problem number 3, again, we're going to distribute, and then we're going to add the 5w squared at the end. W squared times w is w cubed. W squared times 2 is 2w squared. And we're adding the 5w squared on. Are there like terms we could combine? Yes, there are. The 2w squared and the 5w squared are like terms because they have the same variable and the same exponent. They both have a w squared. So we could combine that to get w cubed plus 7w squares. What I'm going to ask you guys to do is pause the video, try the even problems, and then play the video back to check your answers. Here are your answers for the even problems of our first page of our notes. Problem number 2, we're distributing 3. 3 times 3p squared is 9p squared. 3 times negative 3 is negative 9. Distributing the y squared times 3y cubed, we'll get 3y to the 5th. Y squared times y is y cubed. Remember, when multiplying like variables, we're adding their exponents. Lastly, problem 6, xy times 2x is 2x squared y. Xy times xy is x squared y squared. And x squared times negative 1 is negative xy. Problem 2 and 4 in the second section is just a little bit different from 1 and 3, such that we're now subtracting a term from our answer after distributing. So when we're subtracting 8y minus 5y, 3y. And lastly, distributing 3p times 2p will give us 6p squared. 3p times negative 2 is negative 6p. And we're subtracting 5 at the end. However, in this case, none of the 3 terms are like terms with each other. Therefore, we can't simplify any further. Going on to our second page of today's notes, we are not only using our distributive property to simplify an expression, but we're also going to use it to solve an equation. You might remember this from a previous chapter. In problem number 1, we are distributing the 3 times the a and 2 in the parentheses, the binomial we're multiplying it by. 3 times a is 3a, 3 times 2 is 6, and we'll tack on the plus 5 at the end. Just like the last page, we're going to combine like terms, in which the left side will give us 3a plus 11 equals 2a plus 4. To further solve this equation, we have a variable on both sides in which I would subtract 2a from both sides of the equation to give us 1a plus 11 equals 4. And then lastly, we will subtract 11 on both sides to solve for a, in which our answer will be a equals -7. Problem number 2, we see that we're distributing on both sides of the equation because we're multiplying by a binomial on both sides of the equation. As you could see, that's notated with the parentheses. So we will distribute. 5 times y is 5y, 5 times 1 is 5, and tack on the plus 2 at the end, and we'll distribute the 4 on the right side to get 4y plus 8 minus 6. We could simplify both sides of the equations by combining like terms. On the left side, we end up with 5y plus 7, 5 plus 2 is 7, equals 4y plus 2, 8 minus 6 is 2. Like the previous problem, there's a variable on both sides in which we're going to subtract one of them. I would go about this by subtracting 4y on both sides, leaving us with y plus 7 equals 2. And lastly, subtracting 7 on both sides to get our solution, y equals -5. Lastly, problem number 3, again, we'll do all the distributing first. We'll combine like terms and then solve the resulting equation. 2n times n is 2n squared. 2n times 4 is 8n plus 18 equals n times n is n squared. N times 5 is 5n plus n times n is n squared. N times -2 is -2n minus 7. Let's go ahead and check to see if there are any like terms I could combine. On the left side, none of these 3 terms are like terms because they don't have the same variable with the same exponent. However, on the right side, there are actually 2 pairs of terms we could combine. We could combine the n squares together to get 2n squared. And we can we could combine the 5 and the -7 to give us -2. There's nothing we could combine with the -2n, so I could tack it on at the end. I'm just going to rewrite our expression on the left here. And as you can see, there's actually something in common between both sides. Both sides has a 2n squared, in which if I subtract 2n squared on both sides of the equation, the n squared term will be eliminated, resulting in our equation 8n plus 18 equals -2 minus 2n. This equation now becomes just like the previous ones where we have a variable on both sides. I think the easiest route to take here is to add 2n to both sides of the equation. So it is canceled out on the right, and it now only appears once in our equation, which would be 10n plus 18 equals -2. And for n, now I will subtract 18 on both sides, leaving us with 10n equals -20. And dividing 10, giving us our answer, n equals -2. Please let me know if you guys have any questions on the lesson, and I'll